Every day we come into contact with many thousands of manufactured objects that are essential to modern life. The vehicles that we travel in, the clothes that we wear, the machines in our homes and offices, the sport and leisure equipment we use, the computers and phones that we can't live without, and the medical technology that keeps us alive. Everything we see and use is made from materials derived from the earth: metals, polymers, ceramics, semiconductors, and composites. To develop the new products and technologies that will make our lives safer, more convenient, more enjoyable, and more sustainable, we must understand how to make best use of materials we already have, and how to develop new materials that will meet the demands of the future. Materials science and engineering involves the study of the structure, properties, and behavior of all materials, the development of processes to manufacture useful products from them, and research into recycling and environmentally friendly disposal. Humankind, materials, and engineering has evolved over the passage of time and are continuing to do so. All of us live in a world of dynamic change, and materials are no exception. The advancement of civilization has historically depended on the improvement of materials to work with. Prehistoric humans were restricted to naturally accessible materials such as stone, wood, bones, and fur. Over time, they moved from the Stone Age materials into copper and iron ages. Design and construction of the International Space Station and Mars exploration rover missions are examples of space research and exploration activities that require the absolute best from our materials scientists and engineers. The construction of the ISS, a large research laboratory moving at a speed of 27,000 kilometers per hour through space, required a selection of materials that would function in an environment far different from ours on Earth. The materials must be lightweight to minimize payload weight during takeoff. The outer shell must protect against impact of tiny meteoroids and man-made debris. The internal air pressure of roughly 15 psi is constantly stressing the module. Additionally, the modules must withstand the massive stresses at launch. Material selection for MERS is also a challenge, especially considering they must survive an environment in which night temperatures could be as low as -96 degrees Celsius. These and other constraints push the limits of material selection in the design of complex systems. Very often, there isn't a material readily available in its natural state to meet the requirements of these complex systems. This is where materials engineers research and develop new materials that are capable of withstanding these extreme conditions. One of the more notable and popular materials that you've probably heard of is carbon fiber. Carbon fibers are fibers about 5 to 10 micrometers in diameter and composed of mostly carbon atoms. Carbon fibers have several advantages, including high stiffness, high tensile strength, low weight, high chemical resistance, high temperature tolerance, and low thermal expansion. These properties have made carbon fiber very popular in aerospace, civil engineering, the military, and motorsports, along with other competition sports. However, they are relatively expensive when compared to similar fibers such as glass fibers or plastic fibers. To produce a carbon fiber, the carbon atoms are bonded together in crystals that are more or less aligned parallel to the long axis of the fiber, as the crystal alignment gives the fiber high strength to volume ratio, making it strong for its size. Several thousand carbon fibers are bundled together to form a tow, which may be used by itself or woven into a fabric. Carbon fibers are usually combined with other materials to form a composite. When impregnated with a plastic resin and baked, it forms a carbon fiber reinforced polymer, which has a very high strength to weight ratio and is extremely rigid, although somewhat brittle. Carbon fibers are also composited with other materials such as graphite to form reinforced carbon-carbon composites, which may have a very high heat tolerance. In 2012, the estimated global demand for carbon fiber market was $1.7 billion, with estimated annual growth of 10 to 12% from 2012 to 2018. The strongest demand for carbon fiber comes from aircraft and aerospace, wind energy, as well as the automotive industry with optimized resin systems. Carbon fiber can have higher costs than other materials, which has been one of the limiting factors of adaptation. In a comparison between steel and carbon fiber materials for automotive materials, carbon fiber may be 10 to 12 times more expensive. However, the cost premium has gone down over the past decade from estimates of 35 times more expensive than steel in the early 2000s. Another very promising material that is still being researched and developed is graphene. Graphene is an allotrope of carbon consisting of a single layer of carbon atoms arranged in a hexagonal lattice. It is a semi-metal with a small overlap between the valence and the conduction bands. Graphene is a remarkable substance on its own, with a multitude of astonishing properties which repeatedly earned it the title Wonder Material. Graphene is the thinnest material known to man at 1 atom thick and is also incredibly strong, about 200 times stronger than steel. On top of that, graphene is an excellent conductor of heat and electricity and has interesting light absorption abilities. It is truly a material that could change the world, with unlimited potential for integration in almost any industry. Graphene is indeed very exciting, but producing it is not easy, especially if you are aiming towards high quality sheets. Several companies are producing graphene today in very small volumes, and there's a lot of research going into developing new ways to mass produce the material in an affordable manner. Most of the graphene produced today is used for research and development in universities and companies. Some graphene-based products are entering the market, but mass production of graphene hasn't yet been achieved. Our understanding and use of materials have evolved over the centuries. We went from using sticks, stones, and bones to iron and copper to carbon fiber and graphene. The study of materials has shaped our civilization into what it is today, and with continuing research and development into new materials, we can expect to see new technologies and innovations that weren't yet possible, and it could change the very way we live. Thank you for watching. Please like and subscribe. I really appreciate it, and I'll see you in the next video.